Okay, today we have a little bit more in section 5.5 and more theorems about polynomial equations. Now, last videos you saw the rational root theorem. We have two more theorems that we are looking at today. The first one is called the conjugate root theorem. Now, we heard the word conjugate back in chapter 4 when we were dividing complex numbers or imaginary numbers. Conjugate, remember we had the same thing but the opposite sign in the middle? Same thing that we're talking about here. So the conjugate root theorem says two different things. The first part is that if we have any irrational roots, they occur in conjugate pairs. Okay, irrational roots occur in conjugate pairs. Now, an irrational number, remember that's something that can't be written as a fraction. So usually when we're talking about an irrational root for a polynomial, we're talking about the square root of something, maybe the square root of 3, for example. So for example, if the square root of 3 is a root, so is the negative square root of 3. Same thing but opposite sign. Or if we had maybe -1 plus the square root of 3 was a root. So is -1 minus the square root of 3. So again, we have the same thing, but the opposite sign in the middle. -1 plus, -1 minus. Okay? This is all for irrational numbers. The conjugate root theorem does address complex numbers also. Any complex roots occur in conjugate pairs as well. So a couple examples again. If we had 3i is a root, so is -3i. And then another similar, if 2 plus 4i is a root, so is 2 minus 4i. So again, we have the same thing, 3i, but opposite signs, -3i. Same thing, opposite signs, 2 plus, 2 minus. Okay, now hopefully this kind of makes sense a little bit too, since the only way that we actually could get an irrational root or a complex root, the only way we can get one of these is if we would have an equation where we square root or where we have to square root both sides, at which point when we're square rooting, remember anytime we take the square root, it's positive or negative. So if we had like x squared equals 5, for example, we'd square root both sides. X would be plus or minus the square root of 5. We would have that positive and negative no matter what. Okay, so let's do a couple problems using our conjugate root theorem. And I'm going to include both of those examples in the same video here, just because they're really pretty different from each other. And we'll call this example 3, since you saw example 1 and 2 with the conjugate, or with the rational root theorem. Okay, example 3 here. A quartic polynomial has rational coefficients. if the square root of 2 and 1 plus I are roots, what are the other roots? Now, the thing about the rational coefficients doesn't really tell us a whole lot. It tells us that we don't have an irrational coefficient, I guess, which really just says, hey, okay, you can use the conjugate root theorem. All right. Now, if we know it's quartic, think about how many roots that we would have total. Quartic would be 4th degree. We have 4 roots, 4 solutions that we're really trying to find. Now we have both of these. Okay, we have the square root of 2. Well, that is an irrational root. So because of the conjugate root theorem, we also need to have a root at negative square root of 2. Same idea here. Okay, 1 plus I, that's a complex number, that's a complex root. So the conjugate root theorem says its conjugate, same thing but opposite sign in the middle, is also a root, which means 1 minus I is another root. Now double check, make sure you're being careful here. We don't change the sign of the real number, the real part of our complex number. We only change the sign in the middle. So it's positive 1 minus I. All right, so even though it looks like we're really only given 2 of our solutions here, 2 of our zeros, we really can find the other 2. Okay, let's do another example using our conjugate root theorem here. What 3rd degree polynomial function has roots at -4 and 2i? Write your function in standard form. Okay, 3rd degree polynomial function here. Think about how many zeros, how many solutions we'll really have. Okay, 3rd degree means we'll have 3 solutions. Okay, we have a root at -4. Now that you know the conjugate root theorem, it is so tempting to say, okay, that means we have a root at +4 also. No, that's not the case. Conjugate root theorem only talks about if we have an irrational solution or if we have a complex root. -4 is a rational number, an integer. So -4 is a root, okay, that's good. If you think about what that would mean in your equation, that means we're going to have x plus 4 as a factor. I'm going to start off writing my equation here. Y equals x plus 4. And I might as well work with this part too. If I know we have a solution at 2i, this is going to look kind of weird, but if I have a root at 2i, x minus 2i would be one of my factors. Think your zero product property for a second too. If I had 2i here, 2i minus 2i, that would give me a 0. Looking back at this 2i again, okay, 2i, that is an imaginary number. It's a complex root, which means its conjugate, -2i, is also a root. So in our equation, we also have an x plus 2i. We got our function. Now let's write it in standard form. We need to multiply this out. And when I multiply this out, I notice I have i's in a couple different places here. And I remember back in chapter 4, when I had the same thing but an I attached, we ended up with a sum of squares, which was one of those things that we couldn't factor before imaginary numbers. So anyway, long story short, I like multiplying this part out first because I know things will cancel out nicely. My first terms give me x squared. The outside I'd have plus 2ix. The inside would be minus 2ix. And that looks kind of weird, but again, remember I is a number. So 2i is my coefficient here in front of the x. And then my last numbers, negative 2i times positive 2i, is minus 4i squared. Those guys canceled out. Remember the I squared is negative 1, so negative 4i squared is positive 4. Still multiply our x plus 4 we had here. Okay, x times x squared is x cubed. Outside is 4x. Inside is 4x squared. Last plus 16. And double check, just make sure we're in standard form. We need our exponents to go from highest to lowest. X cubed plus 4x squared plus 4x plus 16. Okay, there's my equation in standard form.